Hi everyone, welcome to the conversion of decimal to binary. A decimal number has a base of 10 because it has 10 digits to represent a number. These are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Whereas a binary number has a base of 2 since it uses only 2 digits to represent a number, and these are 0 and 1. So we can convert a decimal number into binary number either by using the sum of weights method or by using the repeated division by 2 method. So let us now convert a decimal number to binary number using the first method, which is the sum of weights method. So in the sum of weights method, we are going to have a representation of a binary number. So we have here our binary digit together with the power of 2, starting from 2 to the 0 power. Okay, followed by 2 to the first power, then 2 to the second power, then we have 2 to the third power, followed by 2 to the fourth power, then we have 2 to the fifth power, then we have 2 to the sixth power, then 2 to the seventh power, and 2 to the eighth power. Here, the weight of each digit increases from right to left, or it doubles from right to left. The first digit has a weight of 1 since the equivalent value of 2 raised to the 0 power is 1. The second digit has a weight of 2. Then the weight of the third digit is 4. The next digit has a weight of 8. The weight of the next digit is 16. The weight of the next digit is 32. The weight of the next digit is 64. The weight of the next digit is 128. And the weight of the next digit is 256. As you can see, the weight of each digit increases from right to left, or it doubles from right to left. Let us understand this more with an example. So suppose we are going to convert the decimal number 230 or 230 base of 10, okay, into binary using the sum of weights method. So how do we do this? Starting from the left, we are going to look for the largest number, which is less than or equal to 230. So starting from here, we're going to look for the largest number, which is less than or equal to 230, and this is 128. So we're going to put 1 under 128. And then we subtract 128 from 230, and the result is 102. This time, we look for the largest number, which is less than or equal to 102. And this is a number 64. So we put 1 under 64. And then we subtract 64 from 102. And the result is 38. Next, we look for the largest number, which is less than or equal to 38. And this number is 32. So we put 1 under 32. And then we subtract 32 from 38. So the result here is 6. Next, we look for the largest number, which is less than or equal to 6. And this number is 4. So we put 1 under 4. And then we subtract 4 from 6. And the result is 2. So this time, we look for the largest number, which is less than or equal to 2. And this number is 2. So we put 1 under 2. Okay, and then we subtract 2 from 2, and the result is 0. So once we arrive at 0 result, what we do next is we are going to fill in those without 1 with 0. So here we have 16, which does not have 1 under it. Okay, same with 8 and 1. So we're going to fill in this part with 0. We're going to fill in this part with 0, and we're going to fill in this part also with 0. The digit at the leftmost part, which is this one, is considered to be the most significant bit. And the digit which is at the rightmost part, which is this one, is considered to be the least significant bit. So this is now our binary number given this decimal number. This is converting decimal to binary using the sum of weights method. Okay, so now 230 to the base of 10 is equivalent to 111001110 in binary. This is using the sum of weights method. We now proceed with converting decimal to binary using the second method, which is the repeated division by 2 method. We are again converting this decimal number 230 into binary, but this time we're going to use this method, repeated division by 2 method. So here, we repeatedly divide the number by 2 until we get 0 as the quotient, taking note of each remainder. So we have here our division operation as well as the remainder. So we are going to start from dividing 230 by 2. The result is 115. The remainder is 0. Then 115 divided by 2. The result is 57. The remainder is 1. Then we have 57 divided by 2. The result is 28. The remainder is 1. Next, 28 divided by 2. The result is 14. The remainder is 0. Then 14 divided by 2, the result is 7. The remainder is 0. Then 7 divided by 2, the result is 3. The remainder is 1. Next, we have 3 divided by 2, the result is 1. The remainder is 1. Then 1 divided by 2, the result is 0. The remainder is 1. Okay, so since we already get 0, okay, as the quotient, what we do next is we write the remainder in reverse order. So this means that we're going to start from here, okay, up to this. Okay, so the binary equivalent of this decimal number using the repeated division by 2 method is 111001110. Okay, so by the way, the digit at the bottom is known as the most significant bit, and the digit on top is known as the least significant bit. Okay, so 230 to the base of 10 is now equivalent to 111001110 in binary. Okay, using the repeated division by 2 method.